with 8.1 and 8.2 mixed in here. The way that this first couple of sections work out is that we're going to talk about graphing right off the bat. How you graph and work with exponential growth, exponential decay, and then logarithmic. We're going to look at all three of those graph styles first. And then we circle back into some of the word problems, which actually are some of the easiest ones that you're going to ever see because they're practical. Depreciation, interest problems, banking, things like that. Extraordinarily easy to work with. So we do that. We'll probably get into that middle of next week. But right after that, the first few days are all graphs. So when we first learned about how to graph, this is y equals 2 to the x. It's kind of tough to type in exponentials here. When we first learned how to graph, what was the first thing you guys always did?
For the vertex.
No, what was the first thing you guys did when you first learned how to plot points? You just picked values, right?
Yeah.
You made a table.
I can't do anything right.
Yes, you can.
I'm never opening my mouth.
Pick easy numbers. Okay?
1. Is that just like 2x? Like, is that an exponent x? Yeah.
Yeah.
So it's 2 to the x?
Yeah. So what I want to do here is I'm always going to pick out very easy stuff to pick to start with. 2, 1, 0, negative 1, negative 2. What we're doing here is we're looking at what's happening around the x or the y-axis, the vertical axis. Okay. We're seeing what's happening around 0. It's a very, very simple thing to do. Now remember, you're just substituting values of x. So you've got 2 squared, 2 to the first, 2 to the 0, 2 to the negative 1, 2 to the negative 2. What are you getting?
4, 2, 1, 1 over 2, 1.
Ah!
1.
1.
Oh, it is? Oh.
Remember, negative exponents means they're just not happy. They're happy. Okay? So those right off the bat give you some nice, easy ordered pairs to plot with. And this is stuff we've been doing many, many times. We start with graphs this way. Make tables, plot points. So at 2 to the negative 2 is a fourth, a half, 1, 2, 4. So your graph is doing that. Okay. Now take a second and put this in your calculator. Plug in your y equals table real quick. Let's take a look at it and see if you can figure out some interesting things. I bet you might be able to.
What, you want to start with the table?
Oh, look at the graph, look at the table, things like that. Now, in this example here, what was our y-intercept? Was at 1, correct? Our y-intercept was at 1. What's the domain of this problem?
All real something negative 2?
All
Real greater or equal to negative.
Well, if you're saying negative 2, but could I have y to the negative third? Or 2 to the negative 3?
Yeah.
Could I have 2 to the negative 4?
Yeah.
2 to the negative 80?
Yeah.
I can't I? It's all real numbers.
So it has to be higher, the y has to be higher.
So then my range, you're saying y values that are greater than, is this going to ever get to 0?
No, because it'll just keep going on and on and on. Getting close, like,
Right, because
It's
those are
just
closer
getting
than
infinitely closer to
it'll be
the
smaller
limit.
fractions.
It's approaching.
Smaller, smaller fractions approaching. When it's approaching something, what is that approachment called that it's approaching?
infinite.
Infinite.
Oh,
Starts with an S and ends in a metope.
Asymptote.
Got it.
I don't know what's, I had trouble spelling that.
THAT.
Oh, no. Asymptote, or S.
Yeah. You say
It's like as.
It was a joke when you said I'm having trouble spelling that.
I know it was, but I was continuing. So many random action here in the y equals.
So what's happening here is you wind up with a horizontal asymptote. You have a horizontal asymptote at y equals 0. Because you're never going to get to 0. You can get, like you're saying, you can get infinitely closer and closer. This fraction becomes smaller and smaller and smaller. So it's getting closer and closer and closer. Do you have a vertical asymptote here? No. You don't have a vertical asymptote because vertical asymptotes occur at zeros in denominators. There's no denominator. The denominator here is 1, so it's not going to happen. All right. Now, what we're doing here is we're going to look at a bunch of different graphs like that. 2 to the x, 3 to the x, 4 to the x, all that kind of stuff. And what these guys are called, what I want you to take a second is plot these, instead of doing it like this, I want to pick a different, pick a different value here. I want to rewrite this as something different here. We just did y equals 2 to the x, correct?
Yeah.
What I want you to do is leave that one in there, but I also want you to change it as y equals 1/2 times 2 to the x. Y equals 3 times 2 to the x. And I want you to look at those also. For that 1/2 times 2 to the x, you can write it as, since you're just putting it into the calculator, you're really not doing anything with it. If you want to use it as 0.5, it's okay. All right? But remember, what's being raised to the x power? Just the 2. All right? Just the 2 values being raised as x, the x power. Just-
They're like, whoa, that's weird. I don't like it.
Oh, it's like a, it looks like a banana.
This one's more like a banana.
Oh my gosh,
It does.
it looks like a banana.
It does.
Oh my god. What are we gonna do?
See, it's a little-
So it looks something like this.
So do
Something
they all
like a
look like
banana.
that?
Yes, me. Oh, banana.
No, wait, you ready?
This is the third dimension of banana. There it is. Oh, it does.
It is a banana.
Now-
It's just like.
You guys are so weird.
It's a banana.
What,
What is that?
now, if you guys look at it, if you guys go to your table, you might see something that's happening.
Oh, that's cool.
Okay? Now, take a look at your table. When x is equal to 0, that's when it's going through the y-axis, correct? You agree? So that means it's going to give you your y-intercept. So the first one, if it depends on how you type them in there, my first equation is 2 to the x.
Yes.
What was my y-intercept at 2 to the x? Say at 1. My second equation was y equals 1/2 times 2 to the x. What was my y-intercept?
1.5.
1/2. My third equation, if you move over to the right,
That's 3.
what's my y-intercept?
3.
3. What is this showing you?
The y-intercept is
The y-intercept is the number before the other one. Narrow that down.
Oh, it's the term, the 3, and then the invisible one.
The invisible one, I like that.
So it's like the,
That's weird. But I like
that's
it.
pretty cool. Wait, what?
The constant, that's exactly what it
Wait,
is.
why did you say that this one didn't have a y-intercept, the last graph?
It did.
It doesn't have an x-intercept.
There's no x-intercept. Okay, there's no x-intercept.
She's not
There's the y-intercept. Where were you going at? What's happening here is that we are looking at a parent function of exponential growth of y equals a times b to the x. This a b to the x is the parent graph. Ladies, come on. I'm not going to ask you this every day, otherwise one of you are moving. Understand? There's 17 of you in here. I shouldn't have to talk over.
That's how many people are in this study.
This is a parent function for an exponential growth model. What happens here with these is that this value of a, this a value is your y-intercept. Your value of a is always going to be your y-intercept. Because what's anything to the 0 power?
1.
1. That's why that works.
Wait, what does this have to do with the 0? Nope, still don't get it.
When you cross the x-axis, or excuse me, when you cross the y-axis, what's your value for x? 0. So anything to the 0 power is what? 1. 1 times something is something. So if we're looking at this, 2 to the 0 is what? 1. 1 times 1 is? Where was your y-intercept?
Oh, okay.
Oh, no, it's 1. Just messing a little bit. This is where your parent functions come from. Okay, so these are exponential growth
I
style.
like how it's talking about like growth. I mean, it's like
I thought
parents
this was like
function,
related to like biology,
family,
you know, growth, decay.
like parents, they grow their exponents.
In their garden.
Love and tears.
So this parent graph formed is a times b to the x. Now, order of operations tells us, please excuse my dear Aunt Sally, which means excuse the exponents coming before the multiplying. That's why this works, because you take care of the exponent first. That's how you're able to identify where your stuff was.
Nice. I forgot about that. Oh, that's so cute.
So, the other thing is, with these growth problems, this is important. The b value has to be greater than 1, and b cannot, or excuse me, b has to be greater than 0 and not equal to 1. Because if b was equal to 1, what would we get? It'd be a line, it would be linear, it would no longer be exponential.
So you can't have a negative z.
Correct.
Nice.
You can have a negative a, because you can have y-intercepts that are -3. It's completely possible. It just means that the graphs are going in different directions. Right? The b value is important between growth and decay. We'll look at that. We'll probably look a little bit more at the decay stuff tomorrow as opposed to today. Yes, guys?
So those are the 5 things you need to find?
Yeah, what's going to happen here, if we go back and think about the graphs you just had, if you think about the y equals 3 times 2 to the x, we had that in our calculators. What was the y-intercept of that? I'm doing the 3 times 2 to the x. The y-intercept for this problem here was at 3. Okay. Was there an x-intercept?
No.
No, there was no x-intercept in this case because the x-intercept was a horizontal asymptote. The horizontal asymptote, so here, was none. The horizontal asymptote was at, is it y equals 0 or x equals 0?
X.
Y equals 0.
I
It's
always do that.
horizontal, okay? Horizontal, vertical, correct.
Yeah,
What's the
what's
code?
what's that supposed to do?
K, H, and K.
This is, what do you think comes next?
Oh, H and K.
H and K. H and K come after parent functions.
Oh.
What was the domain for this? It was all real, because it wasn't bounded.
Is it going to be all real for all of them?
For the domain for the exponential growth of k, they should be, yeah.
When you say should be, then does that mean they mostly will be?
Yeah, I can't think of an exponential growth problem that doesn't have
And
it.
then the range has to be bigger than 0?
The range for this particular function was y is greater than 0. Okay? Y is greater than 0 in this case because you have that horizontal asymptote, and this graph was going from left to right, increasing.
So does it depend on those? You did it. But so does that mean that if like the horizontal asymptote was at like -3, that it would be range is greater than -3?
Correct. And then to get that horizontal asymptote down at -3, what would you have to have had? A vertical shift downward.
Oh.
And that's your H and K then. All right. This is where that, remember when we did H and K last semester, this is the idea that you really didn't need to do parent graph to horizontal to do your shift after that. But I was trying to get you guys in the habit of doing that because this is where it all comes to fruition because it becomes so much easier to plot by putting those both together. All right. Lynn?
I'm still right.
What are you still writing?
Information on the domain.
Wait, is there a reason the stars there, or is that just?
No, I was just,
so we could pose.
so I did this.
Oh, I was trying to figure that out. I thought it was kind of wow. Right in my head.
We are the stars.
Is that a tear?
Do you feel better now?
Now I kind of feel like I said.
Here. Here you go. Here. Feel better now?
Mike would, we're gonna, he would just be rapping right now.
Does this look familiar?
No, maybe.
if you have those H's and K's.
That looks like the series thing, like with the thing
Wait,
up
so
there.
do the H's and K's like?
Not a fan of that.
Like the.
Move it up and down.
Moves them up and down, left and right.
Yeah.
Yep, exactly. It's exactly it.
That's what this is.
So that's like a really important.
I thought that was intimidating when you're doing like this, or you're just being a band director on crack.
Dude, she curved it huge though.
Now, in this case here, these H's and K's, still stand for the same thing as we were looking before. Your A value for this is always going to be your what? It's always going to be your y-intercept. Your A value on growth into K models will be your y-intercept.
What is this called?
These are growth and decay functions. Exponential growth and decay.
Talk about the equation.
Exponential growth or decay. What do you think the H was? It's your horizontal shift.
And your K is your vertical. I'm getting there.
Did you prefer part final? Yeah, okay, it said that. I was like, there's no way I can look at really like that.
If you want to see your raw scores, I can show you.
I want to know.
Of course.
I don't even understand what it is.
Yes, ma'am.
How much did you like hurt them?
I'll show you your raw score.
What if we don't want to see her raw score? We just want to know what's going on.
Because I saw it, I was like, don't see
So
that.
like basically like we're just gonna cut out like the ones that like is the equation like even and stuff. Yeah, like what is this like average person?
Do you know where C is?
Hey, let me ask you a quick question. If it's a fourth degree polynomial, how many changes of direction does it have? 3. All you do is plot it, look for which one of those sets of ordered pairs will give you 3 changes of directions. That's all you have to do.
I saw it in chapter 1. That was my worst.
Yeah, that was,
It was even. It was an even spread.
I was,
Fully even spread.
I
So now, when we get into graphing these things, guys, what we're going to start out with is I'm going to start with non-shifted things, and then we're going to build out of it. Okay? We're going to build out of this. Now, in this example, there is no H and K. Do you agree?
Yes.
There's no H and K, so your H and K here are both going to be at 0. Now, just like we did a little while ago, when we were working with graphs, these are going to be things where we're going to have calculator, non-calculator. So you got to be able to come and create tables without using your calculator here. We're going to use easy values again. -2, -1, 0, 1, and 2. Okay. We're going to substitute into the function 1/2, 3 to the -2, 1/2 times 3 to the -1, 1/2 times 3 to the 0, 1/2, 3 to the 1, and 1/2, 3 squared.
So can we pretty much always just use -2, -1, 0, 1?
Yeah, it's not a bad idea to do that because because you start getting too big or too small. It's for exponential growth. It's obviously they grow rapidly. And I say quickly, rapidly. That's exponential. Now, what's 3 to the -2?
1/9.
1/9.
Oh, so it's 1/18.
1/18. Very good.
It's really small. Oh, that's good. How do you understand?
3 to the -1.
So it's 1/6.
1/6. 1/2. Well, 3 to the 0 is 1, so it's 1/2. The next one is 3/2.
And then the last one is
9/2.
9/2.
Okay.
I'm at peace with fractions.
Now, obviously, in this example here, it's tough to do these small fractions on a 10 by 10. So, can I just do this and say thanks for it? And then just make my own?
Yeah.
Is there any rule with that that says I can't do that? Because what we're doing here is just looking at a visual representation of what it is. Does it have to be scaled to fit a 10 by 10? No. Could you change the scale on that 10 by 10 to say that they're going by quarters? You could do all that. Think outside the box. Literally, we are outside of this box.
I like that.
Good one.
So we'll call this 118. 0 and a 6. There's a 6. Here's 1.
It's so weird how they're all like
Oops.
the same shape.
1 half.
Yeah.
Sorry. Call that a half.
Murphy doesn't need to scale. We can do whatever we want.
There's 3 halves.
That's like 4.5, right? So I need.
Yeah, well, you know, I got 2 words for you. Deal with it.
So it's just not having people like proper scale at all.
No, because
Never really does.
can I still identify what my horizontal asymptote is?
Yeah, you know what?
What is it?
Zero. It's a good question.
Is it 0?
Yeah.
Is it x equal or y equals?
X. Wait, no, because it's on the y, or it's on the y, yeah. That always confuses me, but.
So our horizontal asymptotes at y equals 0. Where's our y-intercept?
I love it when you use that thing. Like
Y
that.
intercept is 1 half.
Is there an x-intercept?
No.
No.
Because
Because the horizontal asymptote is 0.
Correct. What's your domain and what's your range?
Domain is
all
all
real and range
Range
is bigger
is
than
y
0.
scale.
I'm so ready to
It's not greater than or equal to, correct? Or is it greater than or equal to?
No.
It's greater than, because it can't be 0.
Very good.
Because 0 is
Okay. Does that make sense?
Yes.
Not so scary, is it? No, shouldn't be.
Wait, don't go on that. Trying to get my name.
Sometimes you'll have x-intercepts, sometimes you won't. X-intercepts might occur when you have a shift, and that's where that comes into play. So let's go and do let's do this one.
I love math. No. It's worth a try.
I don't know what it is. It's a song.
Let's try this. Y equals negative times the quantity 3 halves to the x.
So
the
negative
y
1 is
is
negative.
The y-intercept now is at negative 1. Good. So what's your a value?
Y equals negative
Your a value is negative 1. Are we okay with that?
1. How do you
It's still
decide
not
that again?
How did I decide that? What's this? From here.
Oh, duh, sorry. That was silly.
It's okay. What's your h value and your k value?
0 and 0.
They're both
Zero.
0, 0. Okay. Now, when I'm looking at this,
Get it. Sorry.
that's okay. When I'm looking at this, I'm going to do the same thing. I'm going to pick easy numbers, negative 2, negative 1, 0, 1, and 2. Now I have to remember that it's negative 1 times 3 halves to the negative 2. Negative 1 times 3 halves to the negative 1. Negative 1 times 3 halves to the 0.
Okay.
Okie dokie.
1 over.
Now, 3 halves to the negative 2. Okay.
9 over 4.
Correct, which is?
Or 4 over 9.
Perfect. So it's negative 1 times 4 ninths, which is? Negative 4 ninths.
Hold on.
Remember, that whole fraction is unhappy.
So you need to
Flip them both.
fraction.
Flip the fraction, then square it. Okay? All right. Negative, or excuse me, 3 halves to the negative 1
Is
Negative
is
1
one.
2
over
thirds.
thirds, yeah, negative.
2, you flip it right away, so it's 2 thirds, so it becomes negative 2 thirds.
0 is negative
0.
Negative
is
1.
Negative 1, because that's your y-intercept.
I'm really
It's
good.
negative
Negative
1
3, negative 3 halves. Got that
And
one.
then this is the negative 1.
Yep, negative 9, this is negative 9 fourths.
Sometimes you don't have to flip it.
See how they pattern out?
I'm just trying to think.
I just saw you go like that.
On the first one.
Remember, you're using order of operations to set them through. All right? You use order of operations to set them up. Please excuse my variance salad. You have to take care of your exponents first. Take care of your exponents, then you multiply it out by the constant. All right. So if I'm looking at this, the plot, negative 4 over 9 is what? About here-ish.
Yeah. Wait, can you like?
Negative 1 is about here-ish.
Worth reducing the fractions or?
Reducing?
Reducing.
Can you simplify 4 nines?
Whoa. Yeah. Wait, no.
Are you gonna, what are you gonna do?
So I'm thinking you can divide each by 2, but that's not right.
No.
Wrong.
No. Negative 3 halves.
no, bueno.
Oh, wait, 9/4 is a little bit more than 2, so it's going to 5. So now look at this graph.
Whoa, what?
Now it's going the other direction. But we're talking about exponential growth, though. This one's going downward, isn't it?
Decay?
No, it's not. See how this is?
It's
This
still
is-
going to the right.
It's still going to the right.
Oh,
Notice-
it's decay with the
Correct. And that's the difference between growth and decay.
The only one.
Growth models, as you're looking at it going from left to right, growth models either increase to the right or decrease to the right. All right? The other ones increase to the left or decrease to the left. And there's a significant difference in the actual function itself. So it's very easily identified when you're looking at the two, which one it'll be. All right? We probably won't get too much into the identifying process today. Oh yeah, I gotta do an H and a K here in a second.
Oh.
So this one, what was your, where's your asymptote?
Zero.
It's still at 0, your horizontal asymptote.
And your vertical is at 0 too.
There is no vertical asymptote here because remember, we're not dividing anything by 0. So we have no worry about, there's no vertical boundary here. Because what's going to happen?
How do you know? Yeah. How do
For
you
what
know
the-
there isn't?
There isn't one for vertical? There's no vertical asymptotes in growth and decay. We don't have that. Because
So
there's
we won't
not,
have one enough.
no, are you dividing by 0 ever?
No.
No, so you're not going to have one. Vertical asymptotes occur when you have a 0 in the denominator. None of this is being divided by x. All right? Then, because if it was, then it wouldn't be an exponential problem. Okay.
Is this gonna get a lot harder?
Well, we're going to do h and k, but that's about it.
That's it?
Yeah.
It's a shift.
So now here your asymptotes at y equals 0. Your domain is all real. What's your range this time?
Hang on, it has to range
Smaller,
is
Is it y smaller than or x is smaller than?
range is y.
Good.
Because
You all right with that? Okay. You just had to look. I want to make sure. All right.
I just.
So,
Yeah.
what you're graphing right now, guys, are just a, b to the x. That's all we're doing. We haven't done a single one with the shift yet. What do you think is going to be the only difference between this and a shift?
You have to
Where-
do it and
H
then.
and K.
Correct. So when we go to a,
Wait, what's the range?
the range in this one would be y is less than 0 because it's bounded above, but it's decreasing. So you can't get, it's going to be all values smaller than 0.
So you just look at the asymptote
Yep.
side then?
Yep. Actually, you're looking at the value of k
Oh. Is it, okay.
because now where's k?
Oh, it's X.
There it is.
Okay.
H is plus 1.
So when we go into this style now, by throwing in the h and the k,
This style.
Wow.
The latest style.
when we start this stuff, we do the exact same thing we just did. We identify the A, B, or excuse me, the A, H's, and the K's. We're going to plot A, B to the X, and then shift it. If I'm looking at this, what's my shift?
One to
One
the
to one,
right,
one
down
and
4.
down.
1 to the right and down 4, because it's X minus H. Okay?
Yes.
Everybody okay that your X values are adding 1, your K values are subtracting 4?
So like it's always like the opposite.
Yes. For this one, because your generic form was X minus H, and this was plus K, so
Positive 1 and negative 1.
correct.
So right one, right
So
one.
Yep.
H equals 1.
So we set up our scenario like we did before. Our A value is 3, our H is 1, our K is negative 4. Which means, yes sir,
How do you find the age?
You know.
it's X minus H, so it is literally that value. If it's X minus 1, it's 1. If it's X plus 1, it's negative 1. So remember when we did this last, whatever, we would write out our shift then was X plus 1 and y minus 4. Remember doing that?
Yes.
You can do the exact same thing now. Find the original set of ordered pairs, add 1, subtract 4. It works just fine. Okay? To start this problem, we plotted out at y equals 3 times 2 to the x, which means your y-intercept is where? 3. To start out, your y-intercept is at 3. Pick the easy values again. 2 to the negative 2 is what?
2 to the negative 1 over 4.
Fourth. So that times 3 is? 3 fourths.
3 fourths.
That's
Good.
like, I can't pronounce
2 to the negative 1 is?
1 half.
1 half,
Multiply by 3, you get?
3 halves.
3 halves. We already identified when it's at 0, it's 3. When 2 is equal to, or excuse me, 2 to the first power is how much?
2 to the first part
Isn't it 0?
2. And then you multiply that by 3, you get?
is 6.
And then your last one is?
So
12.
4.
Oh, so you don't worry about the -1, -4. I'm not doing this as well.
We did. We did it out loud. 2 to the negative 2 is 1/4.
On the original one, like that.
Oh, no. We plot the parent first. Then we shift it. Just like we did before, we plot the parent with the dotted line, then we shift everything with the solid. Okay? So,
Wait, hold on.
We've already gone all,
Wait, hold on. Okay, so right now you're graphing it like without the like H and K.
correct.
You're just doing like the Y
The parent.
times
Yep.
A, B, yeah.
Yep. That's how you always start these.
Okay.
For
And then
every-
once you like graph that, you shift that based on the H and K.
Yeah, because these are your parent ordered pairs. To these ordered pairs, you do this to get your shift.
Okay, are we gonna have to like write out the parent or the other order?
It would be a very good idea to do that because when I do tests and quizzes on this stuff, it's non-calculated
Okay.
for graphing. Okay. When we get to the word problem stuff, it's a little bit more model where you have to use a calculator because you really can't do any of that in your head. It's nasty. But this stuff, I want you to be able to crank by hand. All right? And the fractions here aren't going to be that awful. So we had negative 2 at 3 fourths, negative 1 at 3 halves, 0 at 3, 1 and 6, and 2 and 12. Okay?
Okay.
Yeah, the parent, remember the parent graph is the graph that's there to help you plot the real graph, if that makes sense. So, yeah,
One negative 1.
I go to the right one, and then I go down, let me change colors here. I go to the right one, then I go down 1, 2, 3, 4. Right one, down 1, 2, 3, 4. Right one. Correct. Down, right one, and down 1, 2, 3, 4. Right one, and this is at 12, so it becomes 11, 10, 9, and then 8. We okay with that?
Yeah.
Now, exactly. Let me ask you this before I do the whoosh. Where's your asymptote? Negative 4. Your asymptote is at your K value. Because your original asymptote went through y equals 0. So to that, you just have to move that asymptote down to negative 4, just like you move everything else. K. So because the K value is your vertical shift, your asymptote is a horizontal line, which is working with the y values. Okay. It's always counterintuitive what you want it to be because math is stupid and they didn't label things the normal way. Okay. So we were looking at this, your horizontal asymptote deals with the y values. The y value has been shifted downward 4, therefore your horizontal asymptote gets shifted downward 4. So your new asymptote is at y equals negative 4. And then here's your whoosh.
Use my sound effect.
Whatever's up there. Okay? Now, if you had to write out those ordered pairs, could you do that?
Yeah.
Not that bad, is it? try another one.
What was the accept?
Oh, this case here, you have an x-intercept, but the problem is when you have to find an x-intercept, your value for y is equal to 0. So you have to solve this equation for x.
So do we just say it
You
exists?
don't know how to do that yet.
So
We
we're
just
just
say it
not.
exists.
It exists, it's somewhere. I'm not worried about finding the x-intercept yet. We'll be able to find the x-intercept after I teach you guys how to work with logs.
And domain, all real, domain, bigger than.
Domain on this case is all real. What's your range?
Bigger than -4.
Perfect. What's bigger than -4? Y or x?
Y.
All right, let's do another one. Let's change this up just a little bit here. Let's say that this is at a value of -2. Okay? We'll change that a value to -2 instead of 1 because it's too easy.
That was such a good. That means.
Oh,
I
A is
love
negative
puns.
So A.
They are pretty funny.
two. A is negative
A is one.
A is
my life.
3, and K is 1.
Take a minute, do it. Parent and shift.
Wait, can you do it?
So next.
We are running a little short here. Just start helping out a little bit.
Negative 1 is past. Whoa. Yeah. Oh, it's -1. That's why. Is this one right?
Paragraph time.
2.
Wait,
Mine doesn't go all the 2 and 1/2.
This is -2 times 1/4, so that's -1/2.
Yes.
This is -1,
Yeah. I thought it was -2.
-2. No, it's not +1 because 2 to the negative just means it's not happy. It doesn't mean that it's negative. So this is, wait, I screwed something up here.
Wait, that is.
Yeah, -4. I'm sorry, -4. I'm looking at it wrong. And this is -8. Sorry. So your ordered pairs are as follows. -2 at -1/2. -1 at -1. 0, -2. 1, -4. 2, -8. We okay with that?
Yeah.
That's your parent. Where's your parent graph asymptote?
At 0.
It's at 0.
3 plus 1.
Okay, so to all of these, we have to do what?
Add 3, or go to the right 3 and then up 1.
Right 3, up 1. Perfect. So I go to the right 3. 1 little, 2 little, 3 little spots. 1 little, 2 little, 3. No. And now where's my new horizontal asymptote?
Oh, it's 5.
no, you haven't. You've just been wrong.
Where is it? 1. Perfect. My horizontal asymptote now is at 1. Oops, that was a horribly drawn 1, but you get the idea. What's my domain?
All
real.
Range.
Y is less than 0.
No. Where's your asymptote now?
Oh,
It's bigger than
it's
1.
less than 1.
Yeah.
Less than 1.
Oh, yeah.
And then the reason that it's less than is look at your A value. Your A value is negative.
Right.
Okay?
I get it.
So work on these tonight.
Yeah, I get it.
Man, the best feeling is when you say,
I only want you to-
I want you to do these tonight, because then you know.
Get it.
Just this first part, okay? There's some parent function graph and then some shift graph. I think there's 4 of each, if I'm not mistaken. If you need extra graph paper, there's some floating around. Work on these tonight, then we'll get into the decay, the difference between growth and decay tomorrow. Tomorrow, it's really not a lot different than this. There's one very subtle change. We should have a lot more time in class tomorrow to get some of the work done, to actually do the homework, okay? I am so excited you have no idea.